Hi, today we will be discussing some college algebra concepts. Specifically, we will dive deep into some word problems that involve areas and volumes. First, it is essential to establish the difference between area, surface area, and volumes of a 2D and 3D object. The area is the amount of space taken up by a 2D object. Take a square, for example, with base b and height h. The area of the square would be base times height. The surface area is the amount of space taken up by a 3D object. As an example, the surface area of a cube with side s would be 6 times s squared. The 6 comes from the sides of the cubes, and the s squared comes from the calculated area from each of the faces, which is s times s, or s squared. The volume is the amount of capacity a 3D object can hold. Taking the cube as an example again, and having the side s, the volume can be calculated as s cubed. Understanding the difference between area, surface area, and volume are influential for breaking down word problems, as we will see in the following example. Let's take a look at a word problem example. Here, the passage tells us that a recently constructed pool is 15 feet wide and 20 feet long. So, if I am imagining a pool, I am placing the length and width dimensions in their respective places, like so. Now, it says that the pool owner wants to make a walkway with a maximum coverage of 246 feet squared. Because we do not yet know the dimensions of the walkway, we can just place it around the pool so that we know it is something we have to figure out. Ultimately, the pool owner wants to figure out how wide the walkway is, so we can identify the width being the distance between the boundary of the pool and the walkway as such. Now, we have our preliminary data that has been extracted straight from the passage. Let's try to merge this information together since it actually relates to one another. For example, the total length of the pool along two sides of the walkway can be calculated to be 20 plus W, and the total width of the pool plus walkway along two sides is 15 plus W. Additionally, we can calculate the area of the pool by multiplying length by width, which in this case is 15 by 20. This gives us an area of 300 feet square. Now we can calculate the total area of the pool and walkway by adding the 246 feet squared obtained from the passage and the 300 feet square we just calculated to get an area of 546 feet squared. Now that we have all the necessary information from the passage, we can start solving the problem. Since we want to know how wide the walkway is, we first want to figure out what the total area of the pool and walkway are. We know we are looking for the area because the pool dimensions were provided in a 2D space in the passage. So, as mentioned in the previous slide, area is length times width, and here the total length is 20 plus 2W, the width is 15 plus 2W, and the area is 546. Now, because we have one unknown variable, which is W, we want to factor out the expression algebraically. So, 20 times 15 gives us 300, 20 times 2W gives us 40W, 2W times 15 gives us 30W, and 2W times 2W gives us 4W squared. When all like terms are added and we set the expression to standard form, which is ax squared plus bx plus c, we get 4W squared plus 70W minus 246 equals 0. The best way to solve the remainder of the problem is using the quadratic formula, since our expression is set in standard form already. Here, a equals 4, b equals 70, and c equals negative 264. When we apply the quadratic formula to our expression, we get two values. One value is 3, and the other is negative 20.5. Because we are talking about the width of a walkway, we can immediately disregard the negative valued answer, since it is physically impossible to have a walkway with a negative width. Therefore, our walkway is 3 feet wide. So, as we see here, the area was used quite frequently in order to solve this word problem. Although we did not use the volume and surface area definitions, it is important to be aware of them since word problems apply them often.